This video will drive the fourth and final kinematic equation. So let's again start with the problem. Mr. Joneschild is riding his bike to school. He is almost stopped at the top of a big hill going just 1.0 meters per second. As he goes down the hill, he has a constant acceleration of 2.0 meters per second squared until he reaches the bottom of the 25-meter long hill. Find his final velocity. First of all, even though this is going down a ramp, we can think of this as being a one-dimensional problem because he's only going in one direction. We'll just consider down the long hill as the positive direction. So when we write down our variables, we have the initial velocity is 1 meter per second, the acceleration is 2 meters per second squared, and the displacement is 25 meters. And we're looking for the final velocity. So if we go to the two kinematic equations that we have so far that could possibly be useful, we find that in both cases we're missing information. So for the first equation listed here, we have final velocity we're looking for, that's good. Initial velocity we have, good. Acceleration we have, but we don't have time. And in the second one, displacement we have, initial velocity we have, final velocity we don't have, but we're looking for, and again, we're missing time. So in both equations, if we were to solve this out, we would have, if we were to write in numbers, we would have two unknowns. So if we've got two variables and two unknowns, we should be able to solve the problem with this information. Instead of plugging in the numbers and solving it for this particular situation, it's useful to solve it in variable form so that then we can have an equation for the final velocity given the initial velocity, acceleration, and displacement that could be used for other problems. So we'll start by taking the second equation and rearranging it to solve for time. We'll then put that equation in for the time in the first equation, and we end up with this. Now, to get to this second step, what I did a couple of steps here. First, I subtracted out the initial velocity from each side, and then I multiplied by v naught plus v. And once you work that out, v naught plus v times v minus v naught just gives you v squared minus v naught squared equals 2ax. You might stop this, pause this right now, and go over and make sure you know how to do that algebra. Finally, if I solve for the final velocity, I get that the final velocity squared equals the initial velocity squared plus 2ax. This is our fourth and final kinematic equation. Let's actually go ahead and use it in this problem. So again, back to the initial information that we were given and the equation we're going to use. We'll go ahead and plug in the information. Notice that when I take the square root, I need to put the plus or minus there. And depending on the particular problem, you're going to choose either the positive or negative root. In our situation, it really only makes sense to talk about the positive root since he was going in the positive direction and continued in the positive direction. So when you solve that out, you get 10.05 meters per second. And if you were to round with correct significant figures, you would have to round that to 1.0 times 10 to the first meters per second. Finally, let's just list out all of the kinematic equations, the four kinematic equations we derived in these four videos. These should go on your note card, and we will be using them throughout the year.